Hi, welcome back. In this video, we will solve the majority element problem on LeetCode. Okay, so what exactly is the problem statement here? So given an array nums of size n, return the majority element. Now what exactly is the majority element? The majority element is the element that appears more than n divided by 2 times. Okay, you may assume that the majority element always exists in the array. Okay, so majority element always exists in the array. So as you can see here, 3 to 3, the majority element is 3 because the length is currently 3 and the 3 number is occurring twice. Okay, and the second example is a little bit more verbose basically. So the second example is 2 2 1 1 1 2 2. So the majority element is 2. Okay, so now how we can solve this problem? So one other thing which I want to point out before moving to solve this problem is that the follow-up question: could you solve the problem in linear time and O of 1 space? And this is something to keep in mind while solving the problem. Okay, so here we will work with the 2 2 1 1 1 and 2 2 elements here. Okay, so let's go to the Excali draw. All right, so here we are having 2 2 1 1 1 2 2. Okay, so this is our input array, and as you can see, what exactly is the length? So 1 2 3 4 5 6 7. 7 is the length. And how many times 2 appearing inside of this array? 1 2 3 4, 4 times. So 2 is the majority element. Okay, so 2 is the majority element. All right, now how we are going to solve this problem? So to solve this problem, what you can do, okay, first of all, we will have a hash map. So inside of the hash map, what we will do, we will traverse through this array and we will write it down. So the key will be the number, which is 2, and we will write down how many times it has occurred. So first time it will be 1, then it will be 2. Okay, then we are having the 1 element here, so 1. So how many times it occurs? So first time it is 1, then we are having 2. Okay, second time, and then the third one is here, so 1 is occurring 3, then we are having 2, so we will update this one, so it will be 3, and then once again we are having 2, so we will update this one, so will be having 4. So we are having 2 4 times inside of the array, and we are having 1 3 times inside of the array. Okay, and that is why the 2 is the majority element. But here what will happen, the time complexity will be big O of n. Okay, because we are traversing through the array, but the space complexity will also be big O of n because we are creating this hash map, right? So the follow-up question is quite interesting. So how we can omit basically the usage of the hash map, and how we can calculate the majority element. Okay, so to calculate that, what we will do, we will basically use the majority element description here. Okay, so what exactly is the majority element? So the majority element is the element which appears more than the n divided by 2 times, where n is the length of the array. Okay, so to solve this problem, we will use the Boyer-Moore algorithm. So I will write it down. So Boyer-Moore. So we will basically use the Boyer-Moore algorithm. And this particular algorithm, basically the Boyer-Moore algorithm, is based on the fact that we will definitely have a majority element inside of the array. Okay, so what I'll do, I'll just grab it something like this, and I will do something like this, and I will just select this one. Okay, select it whole and put it down here. So how we are going to solve this problem? This algorithm is quite simple, but coming up with this algorithm is quite tricky. Okay, so in case if you do not understand or you are not able to come up with the solution at the first go, so don't worry about that. Okay, so what we will have here, we will have a result which will start from 0, and we will have a count or frequency basically, which will start from 0 as well. Okay, all right. Now here we will check if count is equals to 0, then we will update the result. Okay, all right. So to update the result, as you can see, we have to have a pointer here. So we will run a simple for loop here. So this is our pointer. Okay, so the pointer is basically here. Now we will first check if the count is 0. Yes, the count is 0, right? So then what we will do, we will update the result. Okay, so here we are having 0 as our result. So now we will update the result. All right, so the result will be this number, which is 2. Okay, then we will check on the same loop basically if the number which we are at currently right now, if this number is equals to the result. If that is the case, then we will update the count as well. Okay, so we will update the count to +1. All right. Okay, simple enough. Now we will go to the next iteration. Inside of the next iteration, here, as you can see, we will check if the count is 0. We will check this one. If the count is 0, no, it is not. The count is 1. Okay, so we do not update the result. All right. Then we will check if the number we are currently at inside of the array, if that is equals to the result. Yes, it is equals to the result, right? So in that case, okay, in that case, what we will do, we will update the count with +1. So it will be 2. All right. Okay. Then we will go to the next iteration. Now, once again, we will check if the count is 0. No, the count is 2 currently right now. So count is not 0. So we will not basically update the result yet. Now we will check if the number, this number is equals to the current result. No, it is not. Then what we will do, we will update the count. So count will be this 2 minus 1. Okay, so this 2 minus 1, because we are not at the same element. All right. If that is the case, then the count will be 1. Okay, all right. Then we will go to the next iteration. Inside of the next iteration, okay, so let me just grab it here and put it down here a little bit. Okay, all right. So in the next iteration, we are having here basically, okay, we are having here, we will check if the count is 0. No, the count is 1. So we will not update the result yet. Then we will check if the number which we are currently at is equals to the result. No, it is not. Then we will basically update the count. So it will be -1. Okay. So then the count will be 0. All right. Then what we will do, we will once again go to the next iteration. Now we will check if the count is 0. Yes, the count is currently 0. All right. So if the count is 0, then what we will do, we will update the result. So what exactly will be the result? Result will be this particular number. Okay. So then we will update our result basically, if I can. Okay. All right. So result will be 1. Okay. And once again, now we will check if this number which we are currently at is equals to result. Yes, it is result. Okay, it is equals to result, basically 1 and 1. So we will update the count to +1. All right. So then we will be basically doing something like this. All right. Now we will go to the next iteration. Okay. Inside of the next iteration, what we will do? We will check once again if the count is equals to 0. No, the count is not equals to 0. All right. Now we will check if the number which we are currently seeing here is equals to the result. No, it is not. Then what we will do? We will decrease our count to -1. All right. So that will be 0 currently right now. Okay. Then we will go to the next iteration. All right. So we are now inside of the next iteration. Now in this iteration, we will check if the count is 0. Okay. So once again, we will check if the count is 0. Yes, the count is currently 0, right? So if that is the case, then what we do? We update the result. Okay. So we update the result. So result to the current number, which is 2. All right. So we will basically update the result because the count is 0. Okay. And then we will check if the current number which we are currently at, basically this one, is equals to the result. Yes, it is equals to the result. Then we will update the count, okay, to +1. All right. So 1. And then we will basically move to the next one. So we will be out of bounds and our algorithm will stop. And at this moment of time, we can basically just return our result. Okay, we can just return the result, which is 2. Okay, I hope that makes sense. And this is the Boyer-Moore algorithm. I know I am basically not pronouncing it correctly, so sorry for that. But this is the algorithm which we will be using. So we have understood the algorithm here. So now let's go to the LeetCode and code it up. Okay, all right. Before coding up our solution, just analyze the time and the space complexity. So the time complexity that will be big O of n. Okay, where n is the number of elements inside of the array. And what exactly is the space complexity? The space complexity will be big O of 1 because we are not allocating any other data structure to basically capture the elements or the basically the number of occurrences as well. So the time complexity will be big O of n and the space complexity will be big O of 1. All right. So now let's go to LeetCode and code it up. So all right, we are inside of the LeetCode. So first of all, we will declare the variable result equals to 0. And then we will have the count or the frequency, whatever you want to call it. I will call it count. That will be 0 as well at the beginning. So for num in nums, okay, all right. Now we will check if the count equals to 0. If that is the case, then we want to update the result. So result equals to the current number which we are currently at. All right. Then we will check if the number, okay, equals to the result which we are currently at. If that is the case, then we want to increase the count, right? So count plus equals to 1. All right. Else we want to decrease the count. So count minus equals to 1. All right. And then after finishing up this one, okay, after finishing up this one, we will just return the result. Simple enough. Okay. All right. So if I just do something like this and all right. So now all of the code is here. So we are having the result, which is starting at 0. Then we are having count, which is starting at 0 as well. So for number in nums, basically this array, we will check if the count is 0, then update the result. Then we will check if the number which we are currently at is equals to the result. That means we are in the same number. Then we will update the count, okay, to +1. If not, then we will decrease the count with -1, okay, and at the end we will return the result. All right, once again, what exactly is the time complexity? That is basically big O of n, and let's do the space complexity. That is basically big O of 1. Okay, I hope that makes sense. Okay, all right, so run the program right now. All right, and submit it. All right, so this is quite efficient as well. Okay, I hope that makes sense. So in this video, we have solved the majority element problem on LeetCode. So in case if you have learned something new from this video, then please like this video, share this video, and subscribe to my YouTube channel. This helps a lot. Okay, and thank you so much for watching, and I will see you in the next video.